Okay, LeetCode 232, implement a queue using stacks. So in this problem, all we're going to be doing is we're going to be using two stacks in order to implement a first in, first out data structure that's known as a queue, right? So basically how a queue looks, if you're not familiar with it, is you have some data. So let's say we have like 1, 2, 3, 4. And basically, if we have a front and then we have a back, right? So the front's going to represent the thing that got put in first, and the back's going to represent the thing that got put in last. And basically, whenever we peek or we pop or do whatever, we're going to be performing it on the front of the queue. This is opposite to what a stack is, because if you remember, a stack essentially takes things in, let's say our order is 1, 2, 3. Well, since 1 went in first, it's going to come out last because we can only pop or peek at the top. So if let's say we want to get the order of this now, remember it came in as 1, 2, 3, but it's going to come out as 3, 2, and 1, right? And this is basically understanding this is basically how you implement this solution. It's basically just understanding that, okay, well, if this goes in this order, we know that 1 went in first, but this reversed it. How do we reverse it back? Well, the answer is just add another queue to the mix, right? So this is S1. Let's say we say that we want to take all of this and we want to put it in S2. So we keep popping. So we pop in the top, 3, 2, 1. So now the 1's at the top as it should be for a queue. And now whenever we peek, we can peek at this stack and see the 1's the front. That's true. Cool. And if we want to pop, we just pop from this, right? And that's all we really have to do. Now, obviously, we don't want to do this for every single operation of a queue, because remember, the queue has 4 different operations in this question. We can push, we can pop, we can peek, and we can just check if it's empty. So we don't want to be doing this movement of data between 2 stacks for every single operation. In reality, the only times we want to be doing this is when we either pop or we peek, because that's really when the ordering of our elements matters a lot. But during those intermediary steps, like when we're pushing or when we're just checking if something's empty, we really don't care what order our elements are in, right? Because like if I'm pushing, I'm not using the data for anything at the current moment, right? I'm just pushing it and saying, hey, I might need this later. But when I do call pop or peek, that's when I should be moving to the second stack. So let's like run through an example. For example, let's say I want to like push 1. I want to push 2. I want to push 3, right? And we'll call this S1. And then I'm done pushing. I just don't now want to say, how about I peek? Like I want to know what's at the front of my queue. So now I do care about the ordering. So what I do is I have S2. All right, and now I start popping. So I do this 3, 2, 1. Cool, right? But now let's say I want to push again. I push, let's say a 4. So I push it here. It's the only element in S1. But now that I pushed, I don't really care about copying it over to here yet, right? That's not really what I care about, because remember, I pushed 4, but a queue only cares about what's at the front, really, right? It cares about that type of ordering. So regardless, since I pushed the 4, right, the 4's here, but the front, right, our pop and peek are only ever going to really care about the front element, but the front element still remains a 1, right, regardless of what's here, because we've already created this. So that's pretty much all there is to it, right? Popping works the same. Like if we push here, this is going to be in the back of the queue regardless. So 1 being in front still matters. But let's say we do pop the 1. So let's say we throw 1 out of here, right? So this is going to be up there. So 2 is going to be, let's say we pop the 2 gets thrown away. Let's say we pop the 3. So the 3 gets popped. Now though, S2 is empty. Right? So that's going to be a very critical thing. Checking if stack 2 is empty or not is going to be very, very important for us. So basically now that S2 is empty though, now we might have to do this again for when we peek, right? If we want to peek, I should copy over this over to here now and say, okay, cool. Well, now 4 is at the front. So this is how the logic works. It's kind of tricky. It's confusing. It's kind of hard to draw out because you're dancing between these 2 stacks, but let's just type out the code. So I'm going to add a little private field here, private, and let's have like 2 stacks of integers. We'll call it S1 stack of integers S2, and S1 is going to be our stack that just holds things temporarily, and S2 is going to be the stack from which we peek and pop from, right? So we don't really have to do anything here. Pushing. Okay, like we said earlier, we're only pushing onto S1. If I kept the drawing right, we're only ever pushing here. So if in this case, if I wanted to push a 5, I'll just push it here. I wouldn't immediately push it there. There's no need. So we'll just say S1 dot push. Right, and I'll just push X. So we'll do that. Cool. Let's do our other one. Let's do the peek first, right? So let's say we just want to peek. So how does that work? Well, the first thing that we mentioned is we want to check that S2 is empty, right? Because if it's empty, we're going to have to do this movement of elements over. So we're going to say if S2.empty, if I can spell today, empty. So if S2 is empty, we're going to do that movement of elements. We're going to say if S2 is empty, so while S1 isn't empty, we're going to take everything from S1 and put it into S2. So we're going to do S2.push S1.top. And then, of course, we should be popping from S1 as we go, I believe. There we go. Cool. But what if S2 isn't empty, right? If S2 isn't empty, that means the thing that we care about being in the front is still maintaining that property, right? So we can just return, basically. We just say that, let's say int result is going to be equal to S2.top, right? And then we'll just return the result immediately. And then notice that we're peeking, so we don't have to pop. We're just looking at the top. Let's do the pop code as well. So it's very, very similar, right? We check again if S2 is empty, right? That means we're going to be copying everything from S1 over to get that ordering that we want, the first in, first out ordering. So we do it while S1 is not empty. We're going to basically push everything from S1. So S1.top. Cool. Then we do S1.pop. Awesome. That's what we want. Now for this, okay, so what we want is we're going to do int result is going to be equal to S2.top. Sorry. So just like our previous problem, so we do this. So we store the result of the top, but then since this is a pop operation, we should pop from that stack as well. So we do S2.pop. Cool. And then we return the result. So that's done, right? Pretty easy so far. This is really the trickiest part, actually. The pop and peek are the trickiest, but that's all that we really need. And then let's check if it's empty, right? The empty check is really, really easy, right? Because if s.empty, so if s is empty, or do we call it S1, sorry. So if S1 is empty, right, all we're going to do is we're going to say, okay, well, there's nothing that we've recently pushed. So let's return S2.empty. So let's just check if S2 is empty, right? Because S1 could be empty, but S2 could not be empty, right? Because we're going to have something like we have in this picture. Let's say we didn't have this 5. Let's say this 5 didn't exist here, right? This is technically empty, right? There's nothing in here, but there's a 4 in S2. So we need to return that check, like if that's the thing, right? Because it could be that they're both empty, right? But in some cases, that's not true. Otherwise, just in case, we'll return false, right? Because if S1 isn't empty, then S2 definitely shouldn't be empty, because eventually at some point in time, we're going to be popping things out of S1 and putting them into S2. That's pretty much it. I don't think there's anything else to really say. I think the only kind of optimization we can do is we can actually do this. since peak returns an integer, we can actually delete some of this code maybe and just say the result is going to be equal to whatever we peak, right? So we peak and we're going to return this, and then we're going to pop and return the result. See if that works. Let's run the code. Awesome, that runs. Let's run the code, submit. Cool, there we go. 100% faster. Of course, this fluctuates. But yeah, runtime. Runtime is really weird for this. So I think it's the challenge for this one that they want you to do is, yeah, amortize one time complexity. So it basically means that like as you perform more and more operations over time, the time complexity as time goes on is going to kind of like, you can think of it as averaging out to being constant time complexity, right? And the reason for that is, like, remember, we had this whole example with these things getting popped, right, and pushed onto here. Remember, we're not doing this every single time, right? We're only copying all the data from here to here if S2 itself is empty, right? But let's say, like, we run through this a couple times, and let's say we're like, okay, well, let's say we pushed 3, 2, and 1 here, right? So these are things on S2. I don't know why this is S4. So S2. So this is here. I can keep pushing like 4, 5, 6, 7, right? I can keep doing this as much as I want, right? And if I'm just peaking, if I'm not popping these things, right? If I'm only peaking, I'm only ever doing it as own one time because I don't need to copy these yet. Like there's no point, right? We don't have to do that. We only care about the front. We only care about what's on the top of this S2 stack. So this is why it kind of over time becomes an O of one thing. Now, obviously, eventually, and at some points in time, we might have a condition where obviously we pop everything out of S2 that we can, and we finally have to push things in here, right? So it becomes 7, 6, 5, 4. But the idea is over time, it averages out to like an O of one type deal. So yeah, that's pretty much it. I hope that this helped. It's a little bit of a tricky problem, but yeah, thank you.